It does say that. Okay, let me look and see. I think Katie said hers did the same. It may not have taken this morning when I did that. So let me double check on that. Cool. And I'll make a note of this too, Hannah and Katie. That way we got it. You're welcome. Cool. Again, remember, just as you're doing this, if you're like struggling, we want to make sure that we've got two vectors going on, right? So we've got the plane vector. That's represented by this and this as the magnitude and direction. And then we've got one of the wind. The wind would be over here. That also would be this direction and this magnitude. And I want you to turn those into I and J, okay? So again, you could do them kind of separate here and rock and roll, okay? Again, just as a good... We lost a little bit. Y'all do this. Are we struggling on the angle?
Yeah, we need to do this, guys.
Okay, cool. Yeah, well, that's why we're doing it. That's why I wanted to go through. I wanted to see how far we could go. Are we just totally off?
Yeah. The first week you don't stare at it. So
Y'all are like really quiet, and I don't know if that's just me or.
I think it's also Monday and a rainy day.
100%. I understand that. How about this? I'll start it off. If you start getting it, you go ahead. Let's see if we can just kind of talk this through, okay? All right, so the plane has a bearing of north 30 degrees east, right? So we'd start at north. We'd go 30 degrees towards the east side, right? So I always start it off this way. I like to connect it to my x-axis. So this thing's going to be going downward here, right? Where this is the I and this is the J. And what would this angle be? 60 degrees, yeah, exactly. And what would the magnitude be again, based on what they gave me? 500, yeah. So we're going to put that. The magnitude is always my hypotenuse, okay? So I've got this triangle that's created, okay? Y'all good with that? Cool. The second one is my wind, which is north 60 degrees east. So this is 60. What would be this angle here? 30 degrees, good. And so we've got J here, we've got I here. What is the magnitude? 50. Okay, good. So now, based on this, y'all get the setup right now? We have a plane, we have wind, right? This equals what my ground speed is. We also call this the resultant vector, okay? All right, so if you're like taking notes real quick, just as a heads up, it's resultant. But before we get the resultant, we've got to find these two in terms of I and J, okay? How do we do that? Nice. Yeah, that's exactly right, Caitlin. So we would say sine and cosine, right? So we would find, but we would use sine and cosine. So how would I use, does anyone know of a shortcut to find I and J? We'll say this is U. We'll say this is V, okay? So this would be like U is equal to, for like the cosine would be related to I or J. Which one? I, yeah, it'd be I because that's the adjacent side, right? So we would say it would be this, 500 cosine of 60, that would go with I, plus 500, what would go with J? Sine of 60 goes with J. Does anyone remember, or can anyone kind of tell me how I got 500 sine of 60? Like, how do I get that?
When you do sine of 60 equals J over 500, you have to multiply the 500 to get rid of the
100%, right? So when we do that, it would take me to this. Here's what's cool. If you know the shortcut, this is always the case. Every time, no matter what. So if you look at the next one, we could find that by doing 50 cosine of 30 I plus 50 sine of 30 J. You just want to be sure that I and J are the correct sign, S-I-G-N, positive or negative. For both of these, what would I and J be? Positive. Good, Katie. Why is that?
I is going to the right, which is positive, and J is going up.
Yep. So it goes to the right, so it's positive, and because J goes up, that also would be positive too, just like Katie said, okay? All right, are we good? David, I know you kind of spoke for the group, I think. I think everyone was feeling this way. Does that make a little bit better sense for you? All right, is everyone feeling okay? Better on this? Okay, cool. All right, so someone throw down in their calculator for us as a group. What would be the U vector when I plug those in? 255?
250I.
250i? Perfect. And then what would be the J? 433? Is it point something or just 433?
It's 0.01.
Yeah, so I guess we could just say 433.0 or just 0. And we'll put that as J, right? All right, here we go. What about over here? With the I's and J's of the second. 25. Perfect. Gotcha there. And there we are. So we've got U and V. Does anyone know how we find the resultant vector now? Yeah, good. So we've kind of got a third side, don't we? Where we add U plus V together to get a resultant vector. And really what this is the plane's moving, the wind's kind of behind it, and so the ground speed is actually moving the plane faster than what it thinks. And that's what ground speed is here. Okay? And remind me, and I'll put this formula on the test too. Plane plus wind equals ground speed. So what would be U plus V?
Oh, wait, 433 plus 25 J.
200. I think it's 250. I know it looks
Sorry.
weird over there. That's my fault. So what is that? 293.3? Is that right? 293.3I. And then what's the J? 458. Awesome. 458 J. Thanks, Audrey. Appreciate it. Thanks, Hannah. So we've got this right here, which is our resultant. Question now. Okay, this is a lot. This is a lot in one problem. 100% understand this. If you get this, though, I think we got vectors. How do I find what the magnitude of the new vector would be? Olivia?
To make a new triangle.
Yeah, so we're going to make a new triangle here, right? Okay? Probably should use this behind me. And the new triangle would be what quadrant?
The first one.
Yeah, and why would it be the first?
They're both positive.
Yeah, because they're both positive, right? Is that a better one right there? Appreciate you. All right, so here we go. We got it here. We've got a vector going this way. We've got an angle that's here that we're solving for. It goes to the right, 293. Rewrite that. 293.3. And then how far up does it go? 458. Nice. Okay. So we've got this is my J, this is my I. How do I find the magnitude? I heard it. Pythagorean theorem, right? It's exactly which is a squared plus b squared equals c squared. Excellent. So we're going to do that. We're going to plug it in. If someone could do that real quick, which would be the square root of each of our values squared. So the square root of 293.3 squared plus, there you go. Good work, y'all. And after you're done with this, you can take a picture of this too off your phone if you've got it. I'm also podcasting this too.
Coach Jay,
Going from there.
I got 543.86.
I like it. 543.86. Thank you very much, Dave. Appreciate you. So this is the magnitude right there. That's like the end velocity whereby the plane plus the wind is equal to with my ground speed, right? And then finally, my direction angle. Here's what I will take. I'll take it in terms of a bearing or just the angle itself. I'll take either of those two options. And how do I find this angle? SOHCAHTOA, which would be, and you could kind of use
Tangent.
no.
You do the inverse tangent of 458 over 10.
Yeah, tan inverse, remember that means angle, right? So tan inverse of my opposite, 458, over my adjacent, which is 293.3, that would equal what theta would be there, okay? So if you just remember, okay, tan inverse of opposite over adjacent, that's how I find what this theta is. It's a good way of attacking it, okay? Tomorrow, especially during the podcast after school, I'm going to hit on another one of these, and that way we can kind of get another rep on it. In fact, I think there's 2 of them that I want to look at off the review. So we'll keep doing these, but I wanted to go over one more before we kind of went into today's stuff, okay? Cool? Cool. After we did this together, I know it's a long process. How does that feel, Dave? Yes.
I just have a quick question.
Shoot.
When we find that angle, do you just want us to round it to the nearest angle? Or like the nearest degree?
That's perfect. Yeah, I think we said for all of these, the nearest angle would be good for the rounding, but the side lengths to the nearest first decimal, if it's got one. If it doesn't, no worries. But yeah, let's do that. What'd you get for that? Just so we got.
I got 57.3, but just 57.
Perfect. Good stuff. Thanks, Dave. All right, is there any part of that process we were struggling with? Here's what I will say. Some of you came in early this morning. Thank you for doing that. Some of us had some good questions off that as well. In fact, who came in early this morning? Just so I remember. You're welcome. Appreciate you. Good stuff. Okay, did y'all get 5.4 homework at all? 5.4 HW? 6.4, my fault. Yeah, 6.4. Okay, here's what we're going to do. Have that ready. I actually said, as far as the note sheet goes, I did not do a note sheet because today is not a whole lot of notes as much as just using the homework. So we're actually going to get homework done today as we go through the lesson, okay? As we go through. Now, let's see, I've got podcasts. We're rolling there. All right, we're Gucci on that. As we're getting ready, someone give me, what's the top thing y'all did this weekend? What'd you say, Hank? What was your dream college?
Where?
Yeah, I know that.
Where?
Cool. That's cool. What'd you do? You may. Yeah. I thought you were going to give me something profound. Anybody else do something cool this weekend?
I was at JC for like 10 hours. Talk to me.
Were you really?
We helped out with Willy Wonka because and we have rehearsals. We were here from 10 to 9.
How'd it go?
Rehearsal was great.
I'm sure there's an inside joke there.
No, I mean like.
We're at 8
I loved it. We helped out
Oh,
with the
pretty
shows.
good.
And the kids are so funny.
Yeah, the kids
Willy
are cute.
Wonka was not like a fantastic show.
I don't like the show in general. Like the show
It's
itself.
just creepy.
Like,
They were cute.
dude, it's an old man who stays watching the factory.
It's weird.
It's weird. The movie used to creep me out. Because his skin is like gray.
Here, I'll give you a story. So I feel like I've got stories for everything, but the Willy Wonka made me realize this before we get started. So completely true story. You know, I make fun of myself. And this was one of those instances. So we were in our rival school, and they were beating us pretty good, actually. They were beating us pretty good. And I went to the free throw line and stayed. I mean, they were all packed. They had a huge student section. And the student section, all of a sudden, I would go to the free throw line, and they started singing a song. I'm like, what is this, a song or something? It's the Oompa Loompa song. I'm like, they call me Oompa Loompa. Oompa Loompa there. So,
Wait, did you have on like a blue uniform?
yeah.
Oh.
Yeah. It wasn't good, because that was our colors. Blue, like it was, yeah.
Did you make the free throws at least?
I did make the free throw, so. Yeah. But we were losing, so it did bad. All right, hey, let me talk over this dot product. I was trying to figure out how I could teach this in a different way. This is the best thing I could find. Other than like going through examples, I wanted to give you just a background, okay? So we talked about how we have 2 vectors, right? And how when we take 2 vectors, vectors are comprised of 2 things, right? What's one thing? Let's see if this... Magnitude, I heard a couple of you say it. Good. Magnitude and direction is what we're referring to, okay? A dot product takes a vector that has 2 different quantities, a direction angle, an I and a j, and what happens is it converts it to a scalar value. What's a scalar value? A scalar value is one common value, okay? So here's the best thing I could come up with. How many of you ever played Mario Kart before?
Talk to me. I'm
All right.
a goat.
How many of you are like legit at Mario Kart? Oh, man.
You
Oh,
can ask David.
wow.
Freshman year, we almost Ann got a lot closer than I did, but we legit almost failed math because second semester Mario Kart came out. It's like all coming back to us now. But Mario Kart came out and we played
Here's your
every
jam?
single day in math. And we sat in the back. Wow, this is so weird. We're sitting in the back of this class. We're failing. Let's go.
No. This is podcasting right now.
Oh,
That's okay.
Hey, keep pushing kids in the future. Keep chugging.
That's right. So, hey, this is the best illustration I could give. Do y'all remember these, like, treads? Like, if you hit them on Mario Kart, it would, like, push you forward, right? So, in essence, you never really thought of this as a kid, but the idea to gain the maximum speed, you would want to hit those, like, straight on. Does that make any sense at all? Because if you hit them kind of sideways, you would get a little boost, but it wouldn't be like a
And
huge
it throw you
boost,
off
right?
on the grass and slow you down.
Exactly. So what would happen is you've got right here a cart that's going this way with a vector that's the blue going this way, and what happens is when they both collide, it creates like one common velocity. Do you remember that? Like it would propel you forward. All right. This is the best I could do.
Did you put those arrows on there?
No, I did actually took this. I was finding a better way to teach it, and I actually found this online. This
I
illustration.
never had those arrows. I was a pro. You didn't have the cheat
I hear it. I hear it. That's back in the day, right? Back in the day. So when we look at this, the boost that you get from two vectors colliding would be like your dot product, okay? Now, that may not be the best illustration, but what I will say is the dot product takes direction and magnitude and combines it to one, all right? Is everyone good on that? All right, let's do this. Can we hop right into the homework stuff? I mean, literally right into it, okay? So what I want to do here is just teach you how do I attack this to convert, and I'll kind of show this. How do I change a vector quantity, right, that has two, direction and magnitude, into a scalar? How do I do that? How do I convert it to where it's one? Kaylin? It's actually very true, very close. There's a little bit more of a tweak than just adding the I and J, because what we have, remember, just like the boost, right, we have two vectors that kind of go in separate directions, and we're changing those things to where it's one, right? And I'll show you where it's used specifically in this context, but you're close, Caitlin. Instead of just adding I and J, does anyone know one other tweak?
Wait, repeat the question.
So we have two vectors, right, that come together, or maybe they go separate. How do I convert those two vectors to one common dot product or one common value? Hannah?
Maybe this is wrong, but could you do that whole x2 plus x1, y2 plus
Oh, that's a good thought. That would be true if I was doing 2 points, right? Initial to terminal. And I'm glad you said that, because this is not as much 2 points as two vectors, right? And we know it's vectors because it's in composite form, right? Well, it's a basic formula, all right? You might want to just kind of jot this on the side of your homework. It's actually taking the i's, multiplying them together, and this is where you were at. Bianca, did you say this?
I was about to.
Oh, you were? Then what would we do before I say it?
You multiply the u times v and then do ac plus
Yeah, what does A and C represent?
good x and like the two x's.
Good, and what does B and D represent? The two y's, and then once I multiply them, what do? You said it. We add them together. Nice. So let's do this, Bianca. Let's do this example together. What would we do to find the dot product of this? Good. -4 times 2 plus what? Good. And then we just combine these two together to get me a dot product. Okay? So we get -8 minus 3, which would get me -11. Okay? So again, these aren't very tough as much as just remembering the formula, which you'll get that formula on the test, just remembering where we use it. Another thing to remember too is if I say this, that is the same as the dot product. So you might want to get that down. That is still just like our Mario Kart illustration, taking two vectors and combining it to where we then take it to where it's just one common value. Okay? Cool. -11 is your answer. That's it. Cool. Just the big thing that I've seen from previous years, people will miss this because they forget the formula. So just kind of rep that out, make sure that you get it, and you should be good. All right, do number 2 on the homework real quick with someone next to you. See if you can do that. Go ahead. So the same is true now. It's the same with the i's being the first value, right? So this is just in linear combination form. We can also change it to composite if that works out for us, okay?
Oh, I forgot you can do that. Because I was thrown off because you can't combine it.
Oh yeah, that's a good point. So you can convert it to that. Either one will work. If you can make that jump, that's fine. Remember, this is linear combination form, and then this is composite form. Just as a review there. Also, while you're finishing this, tomorrow we're going to play Deal or No Deal. Coach J versus the class. That's actually pretty cool. It's going to be good. Hearts will be broken. It's going to be great. There will be. And some decent prizes, too. No. How many bottles? All of these. Now that would be legit. Is that what you expect? Should. I paid for all of the comments, you know. You good? Hey, what'd you get here for this value?
-12.
Good, Jake. Yeah, and good, David. -12 would be the answer. That's it. What's up, on? So yeah, we would say -12, right? -12. Are y'all good?
Yeah.
Can we keep going?
Yeah.
All right, let's continue on the homework just because we're going to get some of this done here, okay? All right, now here's the second kind of checkpoint, okay? There's not a whole lot of checkpoints that I have. This is kind of the final checkpoint before I kind of allow you to rep these out. I think I've got a couple other ones that are solving ones, but this is really the big one that's next, okay? All right, so if I say take these two vectors, find the angle between them, okay? So go back to my illustration here, okay? I know a lot of you did this as a kid. When you saw this vector here and the vector you created, I know a lot of you went and said, okay, I need to screenshot this and find the angle that's between both of my vectors, okay? To back, Caitlin, I see that look. I see it. Kind of
Talk to her, Coach J.
So we have two vectors that are created, and we're trying to find the angle between them, okay? All right, so if I were to draw this out, just as a kind of a heads up on this, take this one out. Let's go straight to the homework one on number 8, I believe. One vector is 1, 0. So if I were to draw this, it would be 1, 0. So it would actually be going this way. Cool. And then 0, -2 would be going this way, right? Now, without looking at the formula, what would be the angle created there? Nice, yeah. You could look at that and just say, oh, coach, that right there is 90 degrees, but how do I find that using the formula? So just real quick, let's try to do this out. The formula created would be cosine of theta is equal to the dot product of UV divided by the magnitudes multiplied together, okay? Again, you know how to do this. It's just executing it. That's it, okay? So if I were to look at the dot product of this, we would multiply what times what?
0 times 0.
Yeah, it would actually be, well, 1 times 0, right? But it'd be 0 plus 0, good. 1 times 0 plus 0 times -2, which would be ultimately 0, right? Y'all follow that? So we have 0 over, well, the magnitudes are, they're kind of irrelevant in this one, isn't it? Why is it irrelevant? Yeah, good, Hannah. 0 over anything is what? 0, right? So we could find these magnitudes by doing a squared plus b squared equals c squared, right? But we don't really have to do it because this is 0. So what we would do is then say 0 over a number is just 0. But what do we set 0 equal to be able to solve? Cosine of theta. Good. So then we say, okay, cosine of theta equals 0. How do I get theta by itself? Inverse cosine. Nicely done. Cosine inverse of 0, once we're in degree mode, would be a value of 90 degrees. Nicely done. Good job, y'all. And that's how we would attack it, okay? So we would say that this is 90 degrees is my angle for theta, okay? Now, that doesn't always work, right? Because sometimes 0 is not true on the top. So that's why you have to do the Pythagorean theorem for both u and v find those once I divide it, get it, and then do the cosine inverse, okay? All right, do y'all feel okay to try the second one on the homework?
Yeah.
You want to try that one? Go ahead and try number 9 using the above formula. Now come around and just make sure we're good because this is a little bit tricky here. Do it over here. That way we got it. Or just have it attack it. Let's try this.
I feel like that one was kind of easier because it's just
Oh, yeah, 100%. Let's start by doing the formula, what we know the formula, right? So what's the dot product of u? How would we attack that one?
2 times 6.
Yeah, 2 times 6, good.
And then
Plus
1 times 4.
negative 1 times 4. Nice, good. And what would we get as our final value once we've done that?
12 minus 4.
Yep. It should be 8. Nice. So in our formula, Hannah, we know that the top is 8, right? We're good there. How do we do the magnitude of u and the magnitude of v? That's a little different right now because we haven't done. Let's do just the right side. So,
Would you just divide? I don't know.
so the magnitude of u, right, would be the square root of a squared plus b squared, right? You know what I'm saying? So this would be like 2 squared plus negative 1 squared. And once I simplify that, right, I would get that and then plug that in for u with the 2 lines, right? The magnitude of that. And then for v, you'll do the same thing, except it's the square root of, what was it, 6 squared plus 4 squared? And you're going to get that answer too, right? Once you get both of those answers, you then divide 8 over whatever the multiplied or product would be of these two multiplied together. Then do cosine inverse of that resultant. Okay? That makes sense in that. I think the only thing I see on that, Jake, is just make sure you add these two or subtract these two together.
Okay.
And then once you do that, you can divide it out there. Get something, Olivia? Pythagorean theorem to do those two. You've got them. Nicely done. Okay. Technically, yeah, it's kind of like multiplication, but we can't just multiply 2 vectors together. What we're doing is the dot product turns a vector that has an I and a j into 2 vectors. It turns into one common value, right? So when I say multiplication, we don't multiply like we would normally do, right? Like remember when we added and subtracted? That was basic, right? That was like what we did today, right? But when we multiply 2 vectors together, right, it's you multiply the i's together and the j's together and then add them, like I said. Yeah. That's just the process of how we would attack it. It's a great question. Rosemary, did you get it? It's good. Yeah, what y'all get for the angle? You're stuck there?
Yeah.
Sounds right. Want to make sure. Did y'all get 40? 47?
It's probably me.
Let me see, I was just looking at the decimals here. Did you multiply these? Check on that. Let's see. Well, let's see it up here, and then we'll go from there. I think it's the 1.7 that threw it off just a little. I think it's just this part. Does that make sense there? So, hey, real quick, let's just make sure we walk through. First off, do you understand that 8's the dot product? Think we're good there? Does everyone understand how to do the magnitude of each of these? Are we good?
We just walk through it.
Yeah, so magnitude is, if I did 2i minus j, right? If I were to graph this, this would go 2 to the right and 1 down. So this would be the, like, vector, okay? So it'd be 2 to the right and negative 1 down. So to find what the magnitude is, we do 2 squared plus negative 1 squared and then take the square root of that. Does that make sense? So it's, if you just remember it's the square root of both of them squared, added together, I'm good with that. You don't have to, you can skip steps. So this is square root of 5, which would be here, okay? And when you do that with the second one, which is v, we would get the square root of 52, okay? So now we're going to say what's square root of 5 times square root of 52. That goes on the bottom. And then we do 8 divided by that, okay? Rosemary, I think maybe I was wrong. I think we maybe right here, and this is something just to remember, is that negative 1 squared is positive, right? So make sure of that just when we do it. Sometimes when you put it in the calculator, it might be off there. So when we do 8 divided by square root of 5 times square root of 52, what do we get? So we've got cosine of theta on this left side. And then we have 8 divided by square root of 5 times square root of 52. 1.33, is that right? Awesome, Audrey, thank you. So what would we do to get theta by itself? Good, Hannah. Yeah, cosine inverse. Nice. Make sure you're in degree mode. Cosine inverse of 1.33, I think that would push it higher to the 80 something. Let me make sure. Let's see, cosine.
Coach Jay,
Is that incorrect?
I think the square root of 5 times the square root of 52.
yeah, how do you type this in the calculator?
Hold up, let me backtrack.
8 divided by.
So 8 divided by this answer. I got 0.4961. Is that what y'all got? I got, so when we do this part here, right? Square root of 5 times square root of 52 and then 8 divided by that. I got 0.4, what was it again? 0.4961, okay? The cosine inverse of that, let's see if we can backtrack here. Hopefully you can see this on my screen here. Cosine inverse of 0.4961 would then be my angle of, I got 60 degrees. Is that what everybody, is that what you got to? Okay, so we get 60 degrees on this. All right, I got some different answers out there. What, maybe you could kind of fill me in. What are we struggling on this? Is it just plugging it in?
Yeah, I think we all put it into our calculators.
Yeah.
Fair.
So then we broke it up.
Wait, how did you put it in?
The way I did it, Audrey, is if I put everything in, this is just my perspective, I get it wrong, okay?
Yeah.
So I'll start by doing the bottom, square root of 5 times square root of 52. And so I get 16.12, okay? I then take 8, divide by this to get 0.4961. And then I'll do the inverse of that to get 60 degrees, okay? Okay? Hey, do this for me tonight. If you could look at numbers 6 and 7 real quick. 6 and 7. On those two, it says find the magnitude. Just do it the way that we know how, okay? There's another way. We're not going to go into that. Just do it the way you know how. And then tomorrow, because I think there's like one other problem I didn't get to. If you want to tomorrow when you come in, have the majority of it done as much as you can. And then what we'll do is we'll go over that last one. And then you could submit it by tomorrow night if need be, okay? I'll allow you to do that. Other than that, hey, have a great day. We'll see y'all. I can actually give it to you now if you want me to.
And I just
But yes, today after school we can look at it.
Right. I know. I was like, okay. There was one person, and they were like,
Maybe I
I'm
messed
pretty
up
sure
on
this is Instagram bio. So I was like, this.
Caitlin, I have yours. I don't know. I didn't put it in, you said?
Yeah.
Gosh, I'll put it in and then I'll give it to you tomorrow. Is that okay?
Okay, yeah. Can I see it?
In fact, I'll do this. I'll give it to you and I'll just write it over there. Okay, cool. So when are your availabilities again? I was trying to. Here's what I'll allow you to do. Okay. Tomorrow before school, I've got Ben Shepard. He's got like a signing thing, so I feel like I need to go to that before his coach. But if you come here before at 7:30, at 7:30 we'll start it. It may be one of those things that I say, okay, hey Audrey, I'm gonna have to move you to maybe my desk down at the end of the hallway, or maybe another teacher's room, and so then we'll move, and then you'll distribution up there. Is that cool? Awesome. So tomorrow morning.
Yes.
Excellent. I'll have that ready. Okay. I won't, but if you turn it in on the left-hand side and I'm not here, I'll leave it open. If not, just slide it underneath.
Okay.
But what will that's shady? I'm sorry. But if you do that, I'll give you full credit because you were here this morning.
Thank you.
Okay? You're welcome.
I still got before 6th period, or like after 5th period.
Yes, at the end of the period, right? Not to do the quiz, just to go over it. Is that or? Oh, to take the quiz.
Because
Let's-
it's just 6.1, 6.2. That's what possibly.
Yeah, let's do this. Do you have first launch on 5th period? Go to first period, 5th period, and then come straight over here and I'll give you the quiz. Cool.